All right, good morning, everyone. Thank you for joining us today for Navigating Change, What to Expect When Reducing Peat Moss. Before we get started, I want to introduce our speaker. Kevin Donnelly will be presenting today. He is Midwest Trading's horticultural soil scientist. Recognized in GPN Magazine's 40 Under 40, Kevin is a dedicated advocate for soil environments. Since 2006, he has spearheaded the Center for Horticultural Soils Testing and Research, otherwise known as CRISTR, at Midwest Trading, delving into a diverse range of soils and substrates, from plugs to green roofs. In his role as horticultural soil scientist, Kevin manages quality control of substrates, oversees raw material management, designs and engineers blends, provides technical support, conducts research and development on innovative components, and contributes to product development and industry processes. So again, welcome. Thank you for joining us today. Before we get started, I do have just a couple of housekeeping items. This is a webinar, so your camera and microphone have been disabled. If you have questions, please type them into the Q&A box. I'll be keeping an eye on those, but we're going to go ahead and most likely just hold all questions until the end of the presentation. So please stay for those. We have a note here about polls being anonymous. I don't think we actually have any polls in today's webinar. However, at the very end, there will be a survey that pops up. So please go ahead and take that survey. In a couple of weeks, this webinar will be shared on our YouTube channel. And also one more point, for those of you who signed up and notated that you would be wanted to receive a CEU credit for this course, you will be receiving an email once the webinar has completed, and you'll want to go ahead and complete that quiz within 24 hours to receive your credit. So with that, I am going to go ahead and turn things over to Kevin.
All right, thank you, Jamie. All right, thanks for everybody for joining us. Again, my name is Kevin Donnelly. I'm the horticultural soil scientist with Midwest Trading. The lab that I work with, we spend a lot of our time on designing products that we make. And so every day we're living this and understanding what's going on with peat moss and pine bark and various other things. So just give it background kind of where we're at. But before I get started on the presentation, I always like to bring up something that I think is rather important to remind everybody of. And when you're growing crops or you're doing anything like that, there is no substitute for scouting. You cannot manage a crop from a desk, right? I remember as a grower being able to walk through a greenhouse and I could see 100 foot down a row, one of the houses, and see the actual flagging of plant material because the light would reflect off of it a little bit differently and go, okay, there's something back there that needs attention. So you need to be out there, you need to be in your crops. And based on what we're going to be talking about today, that becomes extremely important, especially when you're making changes, right? And things aren't going to necessarily grow the way they used to. So really get out there, watch what's going on, learn your crop so that you can deal with that. So why are we talking about this? What is the deal with peat and what's really driving this conversation? Certainly there's been a lot on the sustainability side of it, but I want to really dive in and peel back the layers of what I feel is a bigger driver for the changes that we've been seeing. Now, certainly there's market and regulatory forces at play here, right? And this is kind of where the sustainability side comes into play. There are government organizations and regulatory bodies that are either pushing or promoting the reduction of the use of peat moss. Certainly in Europe and certainly in England, there are bans that have been starting to be put into place. Europe is looking at as well. What can they do about that? Now, to talk briefly about the sustainability of peat, because I do want to touch on that, although not dwell on it. Certainly what it is, it's strip mining, right? You are pulling off layer by layer over the years and what has taken time to accumulate. However, on the flip side of that, so when you look at peat moss in Europe, there's a very specific conversation that has to happen. They've been using it for all sorts of reasons, for fuel and everything else in Europe. In Canada, however, Canada is only being used for horticultural peat. That's the only reason that they're harvesting these peat moss. In Canada, when you look at peatland as a whole, right, the land that has been classified as a peatland, that type of wetland, less than 0.02% of that land mass is being utilized for horticultural purposes. There is potentially more damage to those types of environments through other sources, right? Through agriculture and industry and various other things that's going on. That biomass, yes, in the individual bog, you are depleting some material, but that biomass as a whole generates 60 times faster than at the rate that we are depleting it. So we are a net positive on accumulation by tremendous amounts on the peatland land in Canada. They are required by law to, certainly to restore the peatland back into a functioning wetland. And they spend a lot of time researching this because they want to make sure they do it right. And what they found is that, they'll use the peat for a certain amount of that land for 15, probably for 40, 50, 60 years to where they're harvesting it. And then they restore it to a functioning wetland. And what they found with the research that they've been doing, that in a very relatively short amount of time, relatively speaking, 10 to 15 years, they can return that plot of land into a carbon sink. To where obviously it's losing carbon and you're evaporating it out, the emissions there, but it turns back into a carbon sink in a functioning wetland within a relatively short amount of time, that 10 to 15 year side. There are companies that are certainly trying to use this as a marketing opportunity. Certainly, they'll talk about there's importance to it, but at the end of the day, it's a marketing thing. So if you are selling to one of those stores that happens to want to have peat reduced or peat free, you don't really have a choice, right? If it's a box store, especially, they yield a little bit more power. But I think what the other ones that are a little bit, I think, more impactful, supply and the cost. What we do in horticultural soils is inherently regional, right? These are cheap and heavy materials that have to be shipped far distances. And so when you look at shipping material various places, freight is a huge component, right? Shipping stuff on truck is extremely expensive compared to other ways that you can move materials. Ocean freight is very cheap. Water in general is very cheap. There are materials that get moved on the water, whether it's up the river or across the ocean. And by ton, they are significantly cheaper to use. We've had issues where we have, in our experience, we've been asked to ship materials across the country, right? We had a soil blend that ended up in Baltimore. And not only the cost was probably 2 to 3 times the freight versus the value, but finding the actual truck to move that material was very difficult. And there is a shortage of truck drivers. This is something that's been long time, coming. And a lot of these drivers are retiring, and there's just not as many people coming into that business, that side of the business to fulfill what we need. So it's very difficult in what we do, moving things around. So you want to try and get things closer merely from a freight cost standpoint. It's really important. And the other thing is that, what COVID has taught us is that how fragile our supply chains really are, and the supply chain management that we go through. We spent, as a supplier, every day worried about our supply chains. This is what typically looks like. So we're talking about coconut coir, for instance, in this case. Coconut coir primarily comes from India. And what they typically do in the past would be ship it through the Red Sea. And COVID really threw out, where containers were, and it made it very difficult to get things in. That subsided. However, if you're aware, there is unrest in Yemen where they are actually attacking container ships. And so normally when you go from India through the Mediterranean over to the US, now they're going around. This is a map of actual ocean freight cargo containers. And you can kind of see, if you look back, there's not a lot going on. And this is just a relative going around the Horn of Africa. Now they are, right? Because they don't want to risk going through the Red Sea and the Suez Canal to where they could be attacked or whatever. So insurances go up, costs go up, and it takes longer to get material. And that still has not subsided, right? We are still experiencing that right now with overseas materials. And so coir specifically, that price fluctuated dramatically during COVID. And so we have to watch these supply chains to understand what's going on, right? Tariffs are now on the table that we have to pay attention to. If the tariffs take effect, right, anything coming out of Canada would have a 25% increase. Hopefully that'll all get worked out and we won't have to worry about it, but it is something that we have to pay attention to. And then weather and climate, certainly the climate is changing, weather is changing. Peat moss is subject to weather, right? If it's a rainy day, a rainy season, and it's not drying down, because what's happened with peat moss is they harvest it off the ground with giant vacuums, and so it's got to be dry. You got to have sunny, windy, dry conditions in order to get volume off of there. Every year we have risks involved with just regular weather patterns, let alone the changing climate, on the ability to actually harvest peat, right? So this is an image of Hurricane Irene, the path that it took back in 2011. And you can see it goes, went through New York, went through the East Coast, but went right up into New Brunswick and Quebec. New Brunswick, Quebec are the two provinces. They were accounting for 60 to 70% of all peat coming out of Canada. Their harvest that year was 25% of expected volume. And so back in 2011, we were all worried about peat moss because it was hard to get, because there just wasn't enough due to normal weather conditions, right? So this weather can play a role. This is some data from the peat industry. This is harvest data that I've pulled out, select stuff. But basically what you can see from this, or what you get out of this, is, again, every year is a little bit of a crapshoot, right? Are they going to have a good season, or are they going to have a bad season? Maybe they're going to get more out. Maybe there's issues with weather. I mean, recently there was heat waves and they were worried about fires. And so they could only harvest at night. So there was restrictions on what they could do in order to get normal material out of the ground. And so we've been dealing with this consistently on the peat side, as far as year over year, sometimes the availability will change dramatically. This last year, there was peat in the Midwest. We don't really get it from Manitoba, and we've had to get a lot of peat from far, far further away in order to get the volumes that we need just to do what we currently do. But I think one of the most important ones to take into consideration is the demand and competition side of this, right? Right now, probably globally, 60% of substrates is made up of peat moss, right? Now, Chris Block is an academic in the Netherlands. He ran a study a while ago, and he projected that by the year 2050, the demand on substrates is going to quadruple, right? 4 times the amount. Now, that's a lot of projections, and projections can be off by certain amounts, but not off by that much. And so the fact that, globally, there's going to be an increased demand on the demand for soilless substrates, that means that in our side where we're working, that becomes a big deal, because if you cannot get enough peat now, or if you have trouble with certain things, when the demand goes up, the price goes up, the availability becomes limited, right? So if they're shipping peat moss to other places, or they're shipping other raw materials around because there's a demand somewhere else, either for food production, they've found that growing in containers has become more and more attractive option for food production, certainly your soft fruits, your strawberries and whatnot. But they're even talking about trees and other things that can be grown in containers in different climates to get around some of the problems that they're having with irrigation, water availability, soil disease, stuff like that. And as global populations, they get more socioeconomically better, right? The more money, they're going to want more things, in which case there's going to be more demand for ornamentals as well. Currently, we are facing an issue of the cannabis market, right? The cannabis market has come into play and it's grown significantly over the years, and they need soil. They need substrate. Primarily, they're using core, because a lot of them are shifting from hydroponic production to a soilless substrate, and core tends to be the first step there. But they have needs, right? And so per square foot, a cannabis operation is probably using 3 or 4 times as much substrate as an ornamental operation. And so that's just that much more material that people are trying to buy, but the volumes haven't dramatically changed, right? So it's more people going after the same limited resources for whatever it happens to be, right? And so we're going to continue to have to watch and understand and grow the different types of substrates, the actual resources that we use to produce substrates, in order to make sure there's enough to meet the demand as it goes forward. So that's kind of what's driving a lot of this. And again, the sustainability side, I think it has value, it has importance, but I don't think that's going to be the main driver for the need to diversify, to reevaluate the substrates that we're using. I think more about the demand and the supply as being more impactful. So what kind of things do you need to look out for, right? What should you be doing as a grower in order to get yourself prepared for this? Now, the first thing that you need to be making yourself aware of is the extension service. There is a lot of noise when it comes to horticulture on the internet, right? There's opinions and there's things that are not necessarily based in fact. The extension service, so the university, the land grant university system has a three-tiered objective: education, research, and extension. So the extension services are there specifically to give fact-based, research-based information to the public. That's what they do. And there's a lot in horticulture from an extension standpoint. eGrow, for those who are actually doing mostly floriculture, ornamental, nursery production, eGrow is a great website. There's lots of resources specifically from academics and extension agents to give you alerts and ideas and education on that. But get yourself educated. If you're doing a search online, and I use this quite a bit, type the word extension to the end of that, and it'll direct you more towards those extension sites versus randomly things that may not be as valid information for when you're trying to understand this. And certainly get educated. And now you guys are already taking the right steps by joining some of these webinars. Take advantage of the free web education that's out there, or the education that's included with different organizations, and so that you can learn as much as you possibly can from the industry. There are plenty of webinars on substrates as well. Just watch out for them. A lot of my counterparts are doing the same exact thing and saying a lot of the same things that I'm saying. And so they can give you different perspectives on it, but we're all kind of pushing similar messages. So going back to scouting and testing, right? If you've been using the same kind of mix for the last 30 years and you need to make adjustments, know that that mix is not necessarily going to perform the same way, right? Prior to all of this, when going in and saying, hey, we want to look at different mixes, you wanted to do the same things, right? Just give me a mix that works the same exact way as the mix that I've been using. You have to set that aside, right? When you're talking about dramatically changing the performance and the physical properties and the irrigation of your mix because it's made of fundamentally different materials, you need to take into consideration to do more testing, to do a lot of trialing, test it out first. I've seen quite a few examples recently of growers either being forced to make dramatic changes or choosing to make changes. And then in hindsight, they had a lot of missteps in that initial year or 2 years because, peat moss, there's a reason why we've been relying on peat moss as a substrate for a very long time. There's nothing quite like it, right? That doesn't mean you have to use it, but there's nothing that's the same, right? Peat alternatives, it's not really the right way to approach it. It's all right, if you're inclined to say, I want to not use peat at all, okay, you've got all these different items in your toolbox, you have to make a mix, but the buffer capacity and the water holder capacity and all the characteristics that make peat what it is and as successful it is as growing crops, you may make some adjustments into how you do it. So lots of additional testing and scouting that you do from the beginning. pH is one of the big ones that you have to pay attention to then. The way you manage pH is going to change depending on the different products you bring in. And so you're going to have to watch that more, right? So pH, classically, right, you want it somewhere in the 5.5 to 6.5 range-ish, right? And so what pH does is it impacts your nutrient availability. At that range, things are available in ample quantities. If your pH goes up to above 7, you can run into issues with iron deficiency. It doesn't mean that the iron's not present. It means that it's not available, right? There was an instance with a grower a number of years ago who had a really low pH to start off their early spring crop, and they had purpling of their tomatoes and their petunias. And so that's a sign of phosphorus deficiency. Now, the issue was probably not that the phosphorus wasn't in the substrate. It was more likely that the pH just wasn't high enough to actually make that phosphorus available. And so you have to understand that is the first line of defense is the pH. You should be always watching your pH. You should be testing your pH as much as you can. Now, how do you manage pH? Certainly when making a substrate, we tend to put limestone in there, right? You put lime in there at different gradations in order to get different effects. The finer it is, the faster it reacts. It doesn't last necessarily as long. So if you get something that's like a flour texture, it's going to have an immediate reaction, right? But 12 weeks later, it may be used up, so to speak. The fertilizers you choose also have an impact on pH. You can have more acidic or basic fertilizers, and so that can help that pH drift back and forth, and make sure you watch it. But fertilizer companies have lists of exactly when you're doing liquid feed, this is what this fertilizer will do. And so you can alter them in order to help balance the pH that you're working with. And if you're acid injecting, and if you have an issue, you want to raise the pH, you can turn it off for a while, and that will help bring that pH up. Bringing it down as well, there's acids that you can apply. Again, look towards extension. I don't have specific recommendations on this is what you should use in every single case because there are so many different cases out there, but the industry is there to support you, right? Your input dealers are there to help you get what you need. And so reach out to your network of support in order to say, all right, this is my exact situation I'm dealing with. This is my water test. This is what I'm growing. And then you need to do X, Y, and Z. And then there'll be recommendations on how to lower that pH or raise it, managing it. Stability of that substrate. So, peat moss, pine bark, a lot of the products we work with, these are carbon materials. And so they will break down over time. And so if you were, for instance, to put sawdust into a mix, you're probably going to get a lot of nitrogen tie-up because the breaking down of carbon uses nitrogen, right? You use nitrogen, the microbes use nitrogen to eat the carbon. And so you don't want to rob your crop of the nitrogen it needs by having something that's breaking down very rapidly. And so pay attention to that, right? The wood fibers, and we'll get into that, they don't necessarily behave as you would expect wood to behave. The coarser the particle, the slower it's going to break down regardless of what it is. Bark on the outside, that breaks down slower than wood, but again, it becomes your particle size is what drives that more. You think sawdust is going to melt, but a wood chip made of the same stuff takes a really long time because it's a very small surface area. So that's something that's a little bit harder to see on the surface, right? When you're looking at something, how is it going to biologically react? But know that that's something you need to deal with. And you may need to increase the amount of nitrogen that you add to a substrate in order to compensate for the activity that's going on in the mix. So don't just assume, well, I used to do 200 parts per million, or I used to do 5 pounds of this. Maybe you need to add something. Industry standard is there's something called blue chip. Blue chip is a 3800 nitrogen. It breaks down, it's utilized during microbial activity. That's kind of the mechanism for converting it. And so it is used as an industry standard kind of in nursery mixes and a lot of mixes that have bark in it to kind of ensure that whatever, stabilize that mix so that when you add your fertilizer, you are adding the recommended rate and it's going directly to the plant. And then the last one, as far as to pay really close attention to, is your physical properties, right? Irrigation is key. Is it going to hold more water, less water? Your particle size distribution of it, that plays a role in its ability to to infiltrate that water, to hold on to that water, or is it going to drain too much? In a substrate, you can, in most cases, you can always irrigate more, right? That may be costly, that may take extra steps. But if you have a substrate that's plugged up and it's not draining and it's holding too much water, you can't fix it, right? It's harder to actually deal with that than the other way around. And so understanding how the physical properties of the substrates you're working with is key. You don't want to make a mistake, right? You don't want to cram material in there, squeeze out the oxygen in the air and the porosity that exists so that you have enough air porosity, you have enough oxygen getting to the root system to avoid disease, to help that plant actually grow the way it's going to be. Matrix potential is specifically plant available water. It's something that labs will test, but it's not something that's common, right? It's used more as a research tool than anything else. But the way you irrigate. So if you're used to walk around and look at the surface of the pot and go, oh, it's dry, it's wet. When you start making changes, you're going to have to change how you evaluate if a crop is wet or dry. Picking it up, if you have a much lighter weight material, walking around and picking it up off the bench to see if it needs water may not work as well. So you have to retrain yourself on the irrigation to make sure that you are optimizing the growth of the crop and not running into problems. And don't just assume that things are going to work the way they once were. Hopefully you won't have to make lots of changes, but be prepared for those changes to exist. And then how you bring this material in, right? There's a lot of growers who will bring in different kinds of mixes and then mix them together. And maybe that's something that you want to do. Maybe you want to bring in, you take your standard mix and add something to it to make slight adjustments to what you're trying to do. How you screen it. Are you bringing it in compressed bales? Are you bringing it in and, coconut coir comes in a compressed block that has to then be expanded. So if you have to go through extra material handling steps, be aware of how that might change when you change the types of mixes. Wood fiber is an example where you might have to change a little bit and tweak things to get it to flow the way you used to, right? Does it work with your potting equipment? Do you need to make changes in that? These things matter, right? It's not necessarily going to behave again the way that you used to see it. So how do we go about this? What do we talk, what is the different changes that you're going to see or the things you should look at? So some cultural strategies that we have. So I want to take a moment here. So stratified substrates. If you haven't read about this, seen about this, there's been quite a few articles published in trade magazines and some research that's been done. It's a really fascinating topic, but basically what you're doing is you're taking a finer mix that's going to hold your fertilizer and then a coarser mix and put the coarser mix on the bottom and the finer mix on the top. What that achieves is that when the plant is small, and again, it depends on the plant, but when the plant is small and it needs more water and it needs that fertility, it's getting that on the top part of the plant. You don't necessarily need fertilizer all throughout it because fertilizer is going to leach out. And so the root system at the beginning is not in the bottom of the pot. And so there's a waste there. And so what they're showing, what they're seeing in the research they're doing is that your irrigation improves, the moisture content throughout the pot is better because you don't have this, the top is drier, the bottom is wetter. You don't want that. You want the water up where the root system is. When the plants get large enough to get into the bottom half of the pot, then you're just really utilizing that for air porosity and and the water that goes in there. There's the cost savings with the fertilizer side of it. And so there's a lot of advantages to be able to do this. That with a caveat of you need the mechanics in order to make this happen. There are growers who are already doing two different potting line, two different pot fillers on the same potting line because maybe they put some in the bottom, put the plant in, move it over, and then fill the top of it, right? So there's some equipment changes that would have to happen in order to make this work. But, if that's something that's even conceivable for you to do, try it, right? Try it by hand first and see if that's something that makes sense. Prove it out by hand and then see if you can justify it from the ROI on changing the way you actually pot up plants and stuff like that. But they're seeing it across the board. They continue to see benefits of doing this. Now, wetting agents. Some of these products are going to be, not holding as much water as they once were or whatever else. But I highly recommend to make it efficient is to include wetting agent in your growing process. Wetting agents, hydrophobic material. Peat moss is hydrophobic. Peat moss, if it dries down, it'll float. It will not take on water. And so wetting agents get applied during the manufacturing process in order to make sure that peat gets the water inside of it. Wetting agents last full efficacy, probably 4 months. And then you're going to start seeing declines in its ability to re-wet, right? It's not dramatic, but it exists. If you're sitting on soil that's, 6 months old and you haven't touched it, there's a good chance that the wetting agent is not really effective in that. So what you can do is you can either do a constant feed, you can do a couple drenches. I personally recommend, no matter what you do, before it leaves the growing environment, goes into the sales environment, hit it with a drench of a wetting agent, right? Give it an extra juice so that when it goes to the retail environment, when it goes to the homeowner and it gets used, every drop of water that lands on the soil surface will get utilized by the plant as opposed to channeling off and draining. Really important if you're hanging baskets that dry out so quickly, but you're going to have better success out the door than if you don't include that. With increased costs we have, and with the the fact that substrates might become more expensive or more issues, consider growing in smaller containers, right? If you used, we've been pushing the container size up over time. I mean, it used to be a lot of flat production, right? A lot of 6-packs and whatever else going out the door, and the industry has shifted up to larger sizes because you can get more money for it. It's more immediate, right? Satisfaction by the homeowners. Like, I'd rather buy a 6-inch geranium because it's nice and big as opposed to buying a pack of geraniums that I'm going to have to wait to see. My personal view is that we're starting to see some demand destruction on the homeowner not wanting to buy that $15 geranium, whatever that cost is. Maybe they'd be willing to buy something smaller again. And so when you buy it smaller, you're using a smaller container. If you can get away with a smaller container, that's less volume of material, right? So you're reducing your demand on whether, if it's the same mix, you're reducing your demand on peat moss, you're reducing your demand on substrates in general. Reusing mix is a strategy that exists out there. It is tricky. I was out at, I think it was Monrovia a number of years ago, and they were heating up reused soil to kill any pathogens, whatever, and then they would incorporate that bark mix, the reused bark mix, at a percentage into their substrate. So if you have the ability, larger facilities where you can, if you're not worried about, you have to manage the risk of obviously disease and stuff like that, but it's something that can be done to then reduce your needs on inputs. And as we talk about these competitions or the availability being an issue, having a system where you're reusing mix can be an option, right? Obviously, there's a lot to it. You got to be very careful with it. Don't just randomly reuse stuff because there can be all sorts of stuff in there. If you're applying herbicides or pesticides, that might be in, residing in the reused mix, or the pathogens, everything else. So some common production mixes that exist currently, just to kind of give you an idea of what we're doing right now. This is a chart for, basically, to summarize this chart in a couple words here, as you get larger in container and longer in crop length, you shift away from peat moss and more into pine bark. That's basically the way that this goes, right? The most common mix that people grow in the Midwest is probably, we happen to call it flat and pack. It used to be the Fafford 3B. Every producer has it. It's going to be about 50% peat moss, 50-ish% peat moss, 20-ish% pine bark, and then some perlite or vermiculite or core or something like that. That is extremely common material. The challenge is that, I used to grow in an 80-20 mix as an annual grower. And we were primarily doing that. And so we would overwinter some perennials just because that was something to do for our customer base. There was nothing left of that mix when we overwintered it, right? That it was just mush, because these products they're going to break down over time. And so pine bark materials like that are going to last longer. Most nursery mixes are going to be 60-70%, pine bark at different sizes, and then some compost and maybe some peat, right? That's kind of the way it goes. I don't recommend going more than ideally 2 years in a pot. Certainly 3 in certain situations is fine. But as soon as you get a little bit further and further, that plant should be, if that plant is not root bound or approaching that, then you grew it in too large of a pot in the first place, right? So you should be cycling up those pots more regularly than 2 years is a little bit much. It probably needs to be shifted up, but that's kind of where that comes from. And so, compost is used quite a bit. Pine bark, bark of any kind is used a lot in mixes as far as where these are concerned. So the other products other than peat moss, the traditional peat moss that we're using, coconut coir. Coconut coir is, again, like I said before, coming out of India. It retains moisture really well. It does not have any issues with hydrophobicity, right? It'll re-wet without any problems. Cannabis growers that's the primary thing that they're growing in. They're probably growing in 100% core or 70-30, 80-20, whatever. So there's a lot of core producers out there penetrating the market. It is something, the pH is 7, 7, 8. If you use core at 100% or north of 50%, I guess, there's a few things here. It does hold on to a lot of sodium and potassium from when it's manufactured, right? There's residual potassium and sodium in there. The concern is, and there's a concept of buffered core that you may or may not have heard of. The idea there is essentially you saturate it with calcium nitrate, which knocks out the potassium and sodium, and then you flush it completely, and you basically end up with an inert material, right? Because the concern is as soon as you start fertilizing, that potassium and sodium will come into solution, and then you'll have a nutrient imbalance. I don't see this being an issue. I think it maybe was an issue when the core that was being produced in the market had higher initial salt content, right? Because they weren't washing it as much. But most of the core that comes into the market, the EC, the salt level is probably less than 1, less than 2, something like that. And so if it's less than that, the odds are you're not going to run into a problem with any of that. Coconut core, though, comes in these 5-kilogram compressed blocks, right? And so it's coming overseas. All the issues we talked about with shipping cost, prices will fluctuate due to ocean freight, the problems we've had with it. You have to expand it, right? It expands really well, but you have to add water, get it to expand, process it, and then incorporate it. And so there's additional handling that has to be dealt with. And certainly in the Midwest, outside is challenging in the wintertime, so you might have to invest in equipment to actually bust that core up indoors during certain times of the year. So you got to take that into consideration when you're talking about coconut core, and it is expensive. Relatively speaking, because of the freight side of it, bringing coconut core into the Midwest is a lot more expensive than it is on the coast because you're closer to the port, right? It's like we talked about before, it's really cheap to move material on the water. Once it hits the port, the price starts going up pretty dramatically because you're putting it on the road and you're driving it or you're, intermodaling it, whatever it happens to be. And so relatively speaking, regionally, core is very expensive to bring in the Midwest. Other parts of the country, not as big issue. And relative to peat moss is relatively cheap here compared to further south, right? The further south you go, the more it's going to cost in freight. And so there's a tipping point where core becomes a little bit more attractive financially than peat moss, depending on exactly where you are from a shipping standpoint. So that's coconut core. On the pine bark side, so we bring in the Midwest, we bring in pine bark up the river. The southeast of the United States has a lot of pine. And so material if you're in the southeast, you're using pine bark quite extensively. Out west, they're using fir bark because that's what they have, right? You're not going to ship these things across the country. That doesn't make sense. But bark as itself, because it doesn't break down and it has a coarser structure compared to peat, right? There's sometimes people are using like a 5/8 or a 1/2-inch pine or a 3/8 or all different sizes that can be utilized, but they provide structure. They actually act as an aggregate. Perlite is still something that gets used quite a bit, and there's a lot of advantages to it. But for some types of mixes, when perlite is as expensive as it can be, pine bark is an option for creating some of that structure. There's different gradations there, like I said, and there's different, some of them have fines in it, some not. It holds water. There is internal porosity within the pine, and so will absorb water. It has a low pH, 4.5 to 5.5. It is not as highly buffered as peat moss is, and so it takes less lime to raise that pH. Peat moss might be 4.5, but it takes a lot of limestone in order to bring that pH up to where you want it. Pine bark, you don't need that because of that buffer capacity. And again, it's really slow to break down. So this is how it comes, at least around here. In places like Michigan and northern Wisconsin, there is bark available locally, right? Now, when we talk about bark, some people will talk about aged bark or composted bark, whatever else. They want aged bark, not fresh. Well, fresh is relative, right? When bark is fresh off the tree, and it's just been debarked, the tree's just been debarked, and they're processing it. There's a waxy resin or a coating on the bark that basically seals the internal porosity away. So it's not gonna hold a lot of water. It's gonna be a coarser material because it hasn't taken time to break down and get some of the fines that you'll see in it. And so if you're right next to the mill, yeah, fresh bark is fresh bark, and you may want to age that or cook it in order to handle that process. For us, we're fortunate, I suppose, in that sense, because it takes 3 to 4 weeks after it's loaded on the barge before we ever see it and process it. So on average, it's probably a couple months old before we ever have a chance to use it. And so it is plenty aged from that standpoint. Southern bark versus northern bark, there is no difference. It's more about the market that exists and the infrastructure surrounding it. There is just so much bark in the Southeast. It is the largest managed timberland in the world, right, as far as an industry is concerned. And so there's a lot of bark to be had. So there's a lot of companies that spend a lot of time processing bark and doing things with it. Whereas in the North, there's just less of that around. And so, it may be a more hit or miss on the consistency of it, depending on where you're getting it from. Some places are going to be very consistent, some places maybe not, but there's just not as much in Michigan and northern Wisconsin and in Minnesota. Wood fiber. Wood fiber is the one that's kind of really being the primary alternative and newer product that people are looking at. Is an extruded heat treated material made from pine wood, right? They take wood chips, they run it through a series of processes, and so it actually sort of forms like a crust around the fibers that makes it not break down as quickly as you might suspect when looking at a fluffy wood material, right? It doesn't break down, like it doesn't have the chemical and the biological reactivity that sawdust has. It is more stable than that. So it can provide structure. I look at wood fibers as kind of a mix, a halfway in between pine bark and peat moss. It holds more water than pine, more structure than peat, and so it's kind of in between the two. There is some potential though for nitrogen drawdown. Don't quite understand it completely. Different sources are going to have different processes, and that may change the way that it behaves. So that's why trialing is so important, right? Trial it for a year, different crops, different situations, and see, do I need to make any adjustments to the way that I produce this product in order to get the same level of quality, that saleable size that I'm looking for? Because don't just assume it's going to do what, the brochure says, so to speak, because it's a brochure, right? Test it in your own situation. And maybe you do need to bump up the nitrogen just a little bit. And that's okay, because then you just look at it and saying, well, here's the advantages, here's the drawbacks. These are the trade-offs that you have to do when changing some of this stuff around. The big one, though, on that certainly some of the producers also talk about is the potential for the drop in pH. So it is not buffered like peat moss again, so you don't need as much limestone. So for every, what is it they've said is for every 10% replacement of peat moss, you should also reduce your lime by 10%. I believe that it is what it is. So basically that you're reducing that lime. Well, what they found is that limestone not only helps bring that pH up, but it helps maintain that pH and buffers against drops in pH over the life of the crop or life of that substrate. And so when you remove lime from the equation, you're not using as much lime, then that lime's not there to help control your pH and hold that pH where you want it in that range. And so there is a potential for critical drops where all of a sudden, hey, why is my pH at 4? I've done everything the same. Well, because there's no lime in the mix, right? The lime's not just there to bring the pH up, it's also there to help stabilize it, which is why a really fine grade, like flour-like limestone, after 12 weeks, it could stop working, in which case then the fertilizers that you choose could bring that pH down. So that's something to take into consideration, to pay attention to. Again, relearning how to grow. It's sold compressed. That's one of the advantages of it. is that it's lightweight, it doesn't take up as much space, but you have to then expand it. And so some of this material, it's so highly compressed that when you expand it, it basically creates this bird nest effect where it bridges. And so material handling standpoint, it will not run through certain equipment. Potting machines can be an issue if it's not processed properly. And so the standard process now for most people is to mix in these wood fibers with another ingredient like peat moss or pine bark or whatever, 70-30, 50-50, whatever. Basically, you mix it together. So when you mix it together, it becomes more homogeneous and it'll also flow more easily, right? You're not having these wood fibers bind together and create this mat. I mean, when we would run it across our equipment, we have 1 3/4 screens on a shaker screen. It would just mat up on top of that and then go into the garbage, which is not great for anybody, right? And so processing it so that you can mix it together with something so it'll flow properly into your pots is huge. And so again, material handling side of it, you may need to adjust your processes in order to adapt to this new product. And that's, initially that's a big pain, but it's something that, eventually overcome, and then it's the no big deal. Recycled paper products like pit moss. So it's cardboard, paper, whatever. It's a cellulose product. It's a material that's out there in the market. There's not a ton of it out there, but it is certainly something that is got some potential to utilize a resource that is currently being, we recycle cardboard for lots of things, but it could be used in a lot of different markets because there's certainly plenty of boxes going around these days, right? And so finding a waste stream, this is taking advantage of a waste stream that already exists and turning it into a value-added material that can be used for substrates. It is extremely lightweight compared to other things, which is great from a shipping standpoint, right? You can theoretically get more on a truck. Has really good water retention, something to try, right? To play around with, try it out. And again, most of this stuff, the recommendations that myself and my counterparts are giving is now is the time to try something new, right? Make space for trialing different kinds of products. If you're making it yourself, great. Bring in some of these materials and try it. If you're buying it in from a manufacturer, talk to them about trying something new based on what your priorities are related to substrates and and what's going on. Try it a little bit here and there, and then decide if it's figure out how would I have to change in order to grow in these products, and then make the adjustments, and you can make the determination if it's something you want to do. Or if we have another supply chain crisis, you may not be left with a choice. Right there, we'd move a lot of pine bark for Midwest, and when we have river conditions that are a problem, in 2019 we had massive flooding on the Mississippi River, in which case then we had to find alternatives to the normal pine bark that we bring in. There have been times in the past where I've had to supplement wood waste in there in order to have something to send so that growers can pot up, right? So we may be left with no choice, right? There may be shocks to the supply chain that force a change to what you're doing. So you need to be prepared, right? This is not doom and gloom, but we have seen with COVID and we have seen with other things going on that our supply chain could just flip on a dime, and all of a sudden you have to make a dramatic change to how you produce because of what's available. Compost. Now, like I said earlier, compost is utilized certainly in nursery mixes quite a bit. It is something that's not as common in greenhouse floriculture production. It just hasn't been utilized as much. There's a lot of different various feedstocks. It provides water retention. It provides some fertility, though I do not recommend using that as I'm going to rely on the fact that this has this much nitrogen in that to feed my crop. Not the way you should view it, right? Empirically, let's just call it like 25% of the nitrogen within the compost, right, will be made available and will mineralize in that first year. Tops 25%. So compost already has a pretty small percentage nitrogen in there, just relative to fertilizer, right? And so yes, it will mineralize. It will provide micronutrients and nitrogen and NPK, whatever else, but don't rely there. but it will provide biology to the mix, which can have some benefits as well into the, the actual performance of the crop. So there's a lot of different kinds of compost out there, but it is not a product, it is a process. Every supplier, every feedstock is going to have slight differences. And so you just need to be aware with it. I certainly, in a nursery mix, 20% probably. Greenhouse mix, 5 to 10. Any higher than that, and there's more risks in growing in smaller containers in a greenhouse, right? You have a shorter crop length. And so if something goes wrong, it's hard to fix it, right? Whereas in a nursery crops, longer term crops are more forgiving, right? You're worried about days in the greenhouse and meeting the window to sell your poinsettia crop or meeting your window to sell Easter lilies. Nurseries, you got a little more time to, to catch up. It needs to be mature compost, right? And that shouldn't be an issue. Reputable compost suppliers are going to provide you with something that's mature, that's not actively breaking down, in which case you run into problems. But there are tests that they run in order to make sure of that. And be aware that there is a thing that exists in that has popped up from time to time. It's not common, but it does exist. There is this persistent class of herbicides that they consider persistent herbicides. The Compost Society is actively trying to deal with it, right? To educate whatever else. And so it's not your normal, Roundup or whatever else. They are not common ones. But there are these persistent herbicides that have made their way through the compost chain that then can impact plant quality. Specifically, crops like tomatoes, which lots of people grow. Tomatoes happen to be sensitive to some of these compounds, reported in one research paper I saw as low as 10 parts per billion. And so really, really small numbers, hard to test for that. And so it's something that compost producers are aware of and they're acting on it. But just know that these things have been known to sneak through. They're used for agricultural herbicides. And so it's not very common, but it is something that has popped up from time to time. Parboiled rice hulls, that's been on the market for quite a bit. It's used somewhat in mixes. It's a sterile additive. It can be used as an aggregate. It comes in a compressed material. It works really well. It can also be used as a mulch. A lot of growers are now using it kind of as a 2-inch, 3-inch layer to help prevent weed seeds from going up or weed seeds from taking root. So it's something to consider. Yes, and I know a lot of growers have tried this. Some like it, some don't. It's kind of a personal choice, but it's a material that can be utilized out there. I'm good. Biochar. So this popped up again recently. I know SunGrow has got Black Bear Biochar, I think is the name. So it's a consistent material that they're producing. I believe they're saying it's a replacement. They're replacing perlite with it in some mixes. I'm not exactly sure. I just saw it in something that they were doing. But biochar is a carbon material that is produced through pyrolysis. So it's low oxygen. It's a stable carbon. There's tons and tons of internal porosity that exists out there. But it needs to be inoculated with something, right? You need to fill those voids with something. So a lot of times people will inoculate it with compost, in which case then you have this material that it's out there. Because otherwise, if it's not inoculated, you could start fertilizing and then it'll absorb all your fertilizer or it'll absorb. So you have to watch out for that. Try it out. Most biochars, out there are, again, this is a process. They are really fine in gradation. I think SunGrow specifically, they're making it coarser. That's not the standard out there. But it's something that they're trying to produce consistently. And consistency is challenging, but there are with these materials. One source is going to perform completely different than another source. So it's something to consider. We've been looking at it on and off for many years now. And so it's out there. It's something that can be tried. You wouldn't want to put this much in your mix. 5% maybe. Too much of it would be an issue. 10% tops probably would be my guess. But it's something, again, to try, right? And some other things that are working on commercialization of it. Talk about wood waste, because that is something that we have relied on in the past. It's not ideal. But what the lessons that have been learned with the wood fibers on heat treatments and processing, some people are starting to reevaluate some of the wood waste and say, is there a way we can treat this to get away from some of the problems of just using it straight, right? Because I would not want to grow in, replace pine bark with wood waste. It would not go well because you're not necessarily guaranteed the type of wood that you're dealing with. Hardwoods are usually a little bit more phytotoxic. They have compounds just inherently in them. Think walnut, black walnut, right? Nothing grows underneath a black walnut because of these anthocyanins or the tannins that are in there that will prevent plants from growing. And so you're going to get a lot of walnut, but you can get a lot of different kinds of species when you're talking about arborist chips or something like that. Can be used, just be aware of what's going on when you do it. It may take a lot more nitrogen to do it. Sugarcane bagasse is out there. We don't really concern ourselves with it in the Midwest because, again, we're not growing sugarcane in Illinois. But it's a resource that's out there. It's a waste stream. And people are always looking at trying to reutilize waste streams for growing crops, right? Because it's something that you can turn this into a value-added material, and then you can solve two problems at once. Miscanthus is something that we've specifically been a little bit more interested in because it can be grown in this region. We saw a lot of promise from it a number of years ago, and so it's something that is on the list that is being explored. I think they're doing a decent amount of that in Europe, where they're growing miscanthus grass and then processing it. And again, it turns into you're taking these organic materials and you're processing it in a certain way to get it to do what you want. Like you can process wood in lots of different ways to get different sizes, chips and fibers and whatever else. Some of these other materials you could do the same, right? It's not just you grind it down and you use it. What other processes can you take into place to evaluate that? So that is where we are going to stop, and we will open up the Q&A. Jamie, if you need to jump in at all, that is the end. So thank you for your attention, and we will look at the questions. All right. So there was a question about coconut coir with salt. So coconut coir, salt's never really an issue. If most of the producers are triple washing it, quadruple washing it, and I have never seen coconut coir come in with high salt content. It's just, I think the industry as a whole has said, this is the minimum standard. We need to get these salts down in order to produce it. But there are a lot of different vendors out there. If you go to one of these shows, there's probably a few dozen people are walking around the show suitcasing trying to sell people coir. So every vendor is a little bit different, but I haven't really seen, there are quality differences between the different vendors, but it's something that is specific to each vendor. So I hope that helps answer the question.
All right. Well, if there's no more questions, we've got a couple more coming in here. Before Kevin answers that, I did want to point out quick for those of you who will be getting your CEU credits, you should be receiving an email at the conclusion of the webinar. So please go ahead and do keep an eye out for that.
All right, so there's a question here about what would be your base proportion of alternates to start to be modified for a particular crop? We basically say, you know what, you can put 10% of just about anything in there and probably not have a problem. So if you're looking at, is it going to do harm, right? Is what I'm adding going to do harm? Start with 10%. And if you don't see any harm with 10% or any dramatic changes, then start going up from there. But yeah, 10% of anything is, you're probably pretty safe to start there from your trial. And we always do things in 5%, 10%, increments, just because, you don't want to get bogged down in, well, it's 7.5% of this, whatever else, do a 10, do a 20, do a 30. And if you're selecting something, obviously considering cost and everything else, and if one of them becomes a problem, you just do a simple growth trial would be, it almost plots a curve where you have whatever the crop is, call it tomatoes, and here's your standard, and it grows, 6 inches. Well, then, and all of a sudden you start to see with more incorporation of this, maybe it starts to go smaller or have less development. And so you almost have a chart with the plant you grow. But yeah, 10% is certainly it. Another question on discuss on miscanthus. So why are we using miscanthus versus other grasses? So miscanthus grass, this gigantic, the sterile miscanthus grass that's been used for biofuels. I think primarily one is because of the size. It's huge, and it grows really really well, and it's been used for other things. The fibers of it are pretty stable. I had a bag. I have to find it somewhere, but I've got a bag of miscanthus grass that was ground down from 2010, and the structure is still there. So it takes a really long time to break down. We looked at corn at one point. Corn, just the structure of the corn, it melted. There was just nothing left of it. And so that's kind of where it is. But there are certainly other things you could look at. But I think just from the sheer size and the amount of biomass that gets produced, that's why miscanthus grass is being looked at. And I think because it's being looked at for other reasons. People have used switchgrass, trying to look at that as well. I've seen that. Willow chips, looking at things that can grow fast and get, that economically makes sense in order to grow that because of those stems. But, bamboo, in theory, in certain places, maybe that would make sense. So that's with miscanthus. So there's a question about receiving soil in October, November, and then not using them until the spring. So the amount of wetting agent that goes in there, certainly if it's not active and it's frozen, or if it's cold, you're certainly not going to see as much activity in the degradation of some of these materials. And so I would assume that wetting agent, unless it's sitting hot for a really long time and it's not biologically active, you're probably not going to see it start to break down. But the initial wetting is really important, right? Water and making sure the right moisture content is there is going to help with the wetting. And so, try it out. If you do see issues with initial wetting for whatever reason, the next time around, you can certainly, if still bringing it in October makes sense, request that they add more, because they typically add more than the bare minimum, right? Because you can add lots of wetting agent to it. Adding more wetting agent is not a problem. I would assume at some point it could be a problem. But you probably have to get pretty high concentrations. I think typical mixes are somewhere between 4 and 6 ounces per cubic yard. Sometimes that'll go up to 8 to 10, and in which case then, it's where that bare minimum is on wetting agent that you need for it to function is probably closer to, I don't know, 3 or something like that. But there's different kinds of wetting agents in there. And so some of them are there for initial wetting, some of them are there for that re-wetting process, and they're gonna hang out, so they're longer chain polymers that'll exist. So I think as long as it's stored properly, you're probably in good shape as far as the wettability of that mix. If you do see something, I would say, have the ability to add wetting agent through your injector system. I mean, it's essentially soap. So, have some available. There's a bunch of different manufacturers of it. It's relatively, the incorporation rate through an injector is very, very small. I mean, it's, 10 ppm or something like that. If I think one recommendation I saw, if you're doing constant liquid feed. So you don't need a lot of it in order to have an impact on the wetting agent. There's a question on, would we use, are there wetting agents you would avoid with these alternative substrates? No, I don't think so. I mean, wetting agents are pretty inert material from that standpoint. There's no interactions that I would worry about. Again, it's like liquid soap. It's a surfactant. It's just there to break the surface tension of the water to allow the water to penetrate into the substrate. Organic wetting agents, there's usually a yucca extract that can be effective. I haven't had the time to really dig deep into it, but I know that when we use them at a much higher rate, and they just don't last as long. But if you're doing organic production, that's kind of what you have to do, in which case then having that as a part of your normal practice during crop growth would be of value, to just kind of re-inoculate it on a regular basis, to watch for it. But no, I mean, wetting agents, I think it doesn't hurt to add wetting agent no matter what you do. And I think it's something that's it's a tool that's underutilized. We don't sell any, we just happen to use it, but I've seen a lot of benefits from incorporating wetting agent, because then you're maximizing your irrigation during the process of growing crops, right? So I highly recommend it. There's a question on what type of pH does the miscanthus have? That's a great question. I don't remember. We did that test. We did some testing on it over a decade ago. I think it was probably pretty neutral. I don't think it was like, 4 like pine bark, and I certainly don't think it was 8 like some of the other stuff like biochar can be. It was probably relatively neutral, but I don't know offhand. But that again, that would be something where the buffer capacity of that substrate, is it going to need more lime or more acid, I suppose, to counteract the initial pH of that material? Any other questions? Again, I appreciate everybody who's attending. You're doing the right things by trying to stay up to speed with what's going on. Try new things. That's basically where we're at right now, to make sure you're prepared for changes that you want to have come or may come regardless of what you're trying to do. There's another question. So the question on miscanthus being invasive, the specific miscanthus that we are discussing, there is a sterile variety that is being evaluated, so it does not set seed. Certainly, the question could be, is it really sterile? And that's something that needs to be looked at. Certainly, if larger scale production is done, to make sure that it is in fact sterile and we don't run into a problem of it being invasive. But yeah, that is part of the conversation. But it is proposed to be a sterile variety that has been evaluated.
All right, great. Well, thank you, Kevin, and thank you everyone for joining. Just a reminder, as soon as the webinar wraps up, there will be a survey that pops up for everybody to take as well. Please go ahead and fill that out, as it helps us determine how we can improve in the future. And with that, I think we will say goodbye.
Thank you, everybody.
Bye-bye.